years. It's my pleasure to welcome you all in this morning. On behalf of Annai Arts and Science College, management, faculty, and students, I warm welcome you for this international conference of second day. I would like to take the time to thank every one of our friends, staffs, and the speakers who made yesterday's session a truly special one, and I hope I would have thoroughly benefited. Prayer works wonders. Prayer should spring from the heart. Thinking of a supreme power beyond all humans, inadequacy is a kind of auto-suggestion. Over to the college choir, the musical ecstasy. Let's begin the session with a prayer song. Thank you for Heavenly Ariels for letting the goodness sparks to the spiritual chain reaction with your angelic voices. I request Mrs. Gladys Tangarubi, Assistant Professor, Department of Computer Application, to introduce the guest speaker of this session.
Thank you, Deepika. I'm very much happy and honored to introduce Mr. B. Krishna Kumar, the resource person of this session. He was born and raised in Chennai and graduated from the National Institute of Technology, Trichy, with a bachelor degree in instrumentation and control engineering, a computer vision, machine learning, and robotics enthusiastic. He moved to the United States in 2017 to pursue his master degree in electrical and computer engineering at Georgia Institute of Technology, Atlanta. He currently works at Sony Electronics as a signal processing and machine learning engineer to develop next generation image sensing and products. He has solid association with computer vision, deep learning, path learning, product development, and testing. Addition, with working knowledge of C++, Python, MATLAB, LabVIEW, PyTorch, ROS, and OpenCV. He is having an exceptional leadership experience in horn communication, decision making, time management, and self confidence. Besides, he loves to cook, travel, and follow football. I hand over the remaining time to our respected guest to enrich our minds with his presentation. Over to Mr. B. Krishna Kumar.
Thank you, Gladys ma'am. First, I'd like to thank the college management and the conference members for inviting me to deliver a talk in this session. It's a pleasure to share my experience and thoughts on an interesting subject, which is machine learning. So let me go ahead and share my screen. So could someone confirm if my slides are shared?
Yes, it's visible. You can go ahead.
Yeah, thank you. So as I mentioned, so today in this lecture, I would like to share a brief introduction to this field of machine learning. Probably this is not the first time you would have heard about machine learning, artificial intelligence, robotics, because this is a ever-growing field and something that's hotly discussed and researched upon, especially in the 21st century. So let me go ahead as briefly introduced by Gladys ma'am before this session. I, I work as a software engineer here in San Jose, California, and I have always been passionate about signal processing, machine learning, and computer vision. That's something that I've always looked upon and been really curious to learn more. And also, I've taken a keen interest in these fields. As already mentioned, I did my bachelor's degree in instrumentation and control engineering in NIT Trichy. So for some of you, you would have known this as REC Trichy. So I did my bachelor's degree in NIT Trichy. And recently, last year, I also completed my master's degree in electrical and computer engineering at Georgia Tech in the US. So I've also listed my contact details, and I'm always interested to connect with people. And if anyone has any sort of questions, you can always reach out to me personally through my LinkedIn or personal email. So before I start the lecture, I just wanted to quickly take you all through a normal day in our lives of some of the things that influences us on a daily basis. So for instance, in the morning, most of us, we start our day by looking at our smartphones for messages. We also like to look at the news, or we have these smart devices like Alexa, Google Assistant to find out what's the news around. We'd also like to know how the weather is. Is it going to be, do I need to take an umbrella? Is it going to rain? How the weather condition is for the week. And we also would like to have some morning exercise, and we'd like to track our how much distance we traveled, our heart rate, and other things. So in the afternoon, we might want to commute to our work or college or anywhere else in our automobiles, which is once again, which contains a lot of sensors and intelligence, which are transformed over the several decades. And we might have to attend a meeting where we need to discuss and think about an upcoming decision that we need to take for our companies or even generally for our project assignments. Then we might also want to catch up on some sport event, watching it through our smart TVs. We might also want to look in our stock trading, how if we need to buy or sell shares, and we want to always keep ourselves updated. In the evening, we might want to go and rest and play games, probably in our PlayStation or PC games or with our friends. We might also want to do some e-commerce shopping, travel, plan our travel for the holidays with families and other things. We might also want to finally catch up with our family, friends, colleagues through FaceTime or Skype. We'd want to chat with them. And finally, we have to also get ourselves ready for the next day maybe for an upcoming meeting and incoming deadline, or probably also a business update. So as we have mentioned, artificial intelligence is there in almost any of our products that we use these days. And so this is something that we cannot uh, miss, because it's there in almost everything that we use, and it helps us enabling our lives. And that's something that I've always been passionate about, and I'd like to just introduce the audience of this talk to on the field. So the agenda for this talk, briefly, I would like to introduce the audience to the field of machine learning. I'd also like to just touch base upon the generalized machine learning process flow, something which would give guidelines on how to think about the field and how we can also design our own systems. I'd also like to draw comparisons between human learning versus machine learning, how they are similar, how they are different. And I'd also like to just briefly talk about the different types of learning problems that's there in this field and also actively researched upon. Then I'd like to focus on some timeline of some interesting events. There has been continuous development of events over the last probably 70 to 80 years in this field, but some of my interesting events that I felt I have dropped down in the slide, which I'd like to uh, briefly discuss upon. Then I'd of course like to draw more applications, some career opportunities, and also more importantly, how to keep ourselves curious and learn more on this topic. One thing that I would definitely like to say in the beginning, this is not a theoretical session, so this is not going to be an hopefully not boring. So this is basically the motivation of this talk is to introduce the audience to the field and uh, make them as curious as how I have been in this field. So here, so what is machine learning? So here I've listed 3 domains, and these are probably the 3 words that all of us have been hearing, whether we see our televisions, whether we look find for new job opportunities, whether we discuss with fellow members in this technical field, and it's artificial intelligence, machine learning, deep learning, robotics. These are topics that always discussed upon in this field. So what is artificial intelligence? So in short, it's nothing but the intelligence demonstrated by machines. For instance, our smartphones and Alexa, Google Assistant, things like these we know that they have the intelligence. Okay, so I have an Alexa at home. The moment I said Alexa, it triggered in my room. So yeah, so it's always there around us, and it always helps us in our day-to-day functions. And with machine learning, it's nothing but a method to learn this intelligence. For instance, a reinforcement learning is one type of learning, which I'll also briefly introduce, which is used in chess and video games and lots of other applications. And deep learning is a subset of machine learning, where the focus is to learn like how we do, like how humans do. For instance, there's been a lot of development in neural networks and these fields. So here I've just dropped down the generalized flow. Just a moment. Yeah, so here I've just dropped down the generalized machine learning flow for any kind of system. So it usually contains 6 phases. So in the first phase, we have a data collection phase, or this is basically what contains the knowledge or the information that we want to learn. For instance, these could be images, these could be text, these could be audio, this could be speech, or any type of media which contains the information. And then second phase, there's always a pre-processing stage where we want to clean, prepare, and manipulate this data. For instance, say we want to have a voice translation application. So we want to convert from, say, a particular language, for instance, English to Spanish. In that case, we want to make sure that the English text or speech is free from noises, background noises, other kind of noises which are not useful. So that's an important step that is usually involved. And then in our third phase is the training model phase, which is the actual step where we learn from data. And then in our next stage, we want to find out how well this performs, and that's the testing phase. And depending on how well it performs, we'd want to either use it in real applications, like face detection, and as I mentioned, text-speech translation. And if they are not up to the mark, we want to retrain them back. So in the next slide, I've just here I've briefly compared with the generalized process flow to how humans we learn, to drawing a comparison with how machines could learn. So for instance, we humans. So for instance, take ourselves as an example. The data here are our textbooks. So we have textbooks, university prescribed syllabus, we have textbooks and other resources, and that's our data. And then in a second step, the pre-processing phase, we have our lecturers and professors who try to share their knowledge that they have gained, as well as what's there in these syllabus books. And there's also an element of self-study where we are also uh, practice to learn from these resources. In such a way, we train ourselves. So here the model is nothing but we are trying to learn from the classroom lectures as well as the prescribed textbooks. And then there's a testing phase. And this is our university examinations, where we are tested upon what would likely be if we are prepared to go and apply this in real world applications. So there could be two outcomes. One, we could pass, we could go be happy and go through our graduation and be ready to apply what we learned in our classrooms to real world applications. Or there could also be another phase where we are not yet ready to uh, disperse this knowledge into real world applications. So we might have to go back to the step of trying to learn more and equip ourselves and train us better. So that's how we human have traditionally, in this example of our university college life, how we see ourselves learn for the outside world. And that's how we could also think of machines to learn as well. Instead of learning from a single textbook, we would want several books and textbooks of data. And this is the big data and the data science field. There's also another field that's uh, dominated in this field, where we have several gigabytes and terabytes of data having to be fed uh, for machines to learn. And then a second stage, there's again a pre-processing phase where we need to feed the right information to our intelligent devices like machines or computers so that they can also learn what is intended for our application. And then they also have a testing phase or an evaluation phase similar to our examinations, and we judge if the machines are up to the mark, if they are good enough to be applied to real world scenarios, then we use them, or we again go back and try to make these machines more efficient in the learning process. So again, one of the main, if you notice in this machine learning process, the last step, the objective of these machines are not for the machines themselves to become intelligent, but the main objective is to make these machines help our lives and help us to make the right decisions in our day-to-day lives. So that's why. So if you notice for the human learning as well as the machine learning, the last step is it helping us to take the right decisions. So here, I just wanted to quickly just introduce some of the variants or types of machine learning. So there are several other topics, but these are some of the frequently discussed topics. These are also actively researched. So these are when we take a look at one of these machine learning textbooks or courses, we would always come across these terms. Like supervised learning is a type of machine learning where we have both, we want to learn from data and annotations. So annotations are nothing but uh, the expected output that are associated with the data. So that's our annotations. And then there's an unsupervised learning where we just want to learn just from data. And then there's a semi-supervised learning where we'd like to learn from data through partial annotations. As the word suggests, it's semi-supervised. So we have half the labels and we want to learn from them. So for instance, say we want a face detection application. So the objective of the application is given an image. We want to find a bounding box around our faces. So how we train this model is feed in 1,000 images of ourselves, of different people, with annotations of the bounding box around the person. So those are our annotations, and the images themselves from our, let it be a camera of mobile phones, or it could be images from the web Google images. or other forms of sources, but these are our data or images that we would want to make our machines learn from. So another type of learning is a reinforcement learning, as I discussed before. So this is a kind of learn through trial and error. So an analogy for this would be a small child learning to walk from crawling. It would always fall uh, subsequently, but eventually it never gives up. So it tries correcting every moment through its way, and eventually it will learn this is how I need to walk. So that's how we also want our machines to learn, through trial and error. Another aspect is also the active learning. Here we want our users to also be involved in the learning process. So we would want to query the user when we are learning. And then there's online learning, as it suggests, it's online, or you can learn sequentially as the data becomes available. And then there's transfer learning, where you want to transfer knowledge from one field to another field, or from one task to another task. For instance, say I have a model trained for voice translation from, say, Tamil to some other language, English, but you could also use the same model to maybe help with Tamil to maybe some other language that has close similarities. So in that way, you're not needing to again collect more data, label more data, and train our models, but just trying to transfer knowledge from one place to another. Another type of learning is also the multitask learning, where we would want to learn multiple tasks at once. So we'd want to learn like translation from Tamil to English, from Tamil to Hindi at one shot. So that's a multitask learning problem. So these are just, there are other types as well, Q learning and also anomaly detection and other types of learning. But here I just wanted to uh, brief upon some of the most common types of learning problems and how they are different. So here are some interesting events. As I mentioned, there have been several other interesting events, but these were some that I wanted to just share upon, some of the things that made me curious and develop an interest towards this field. For instance, in 1950, the British mathematician Alan Turing, so he came up with a test called the Turing test, where can a machine fool a human? So that's a very high level explanation of the test that he came up with. But indirectly, it's nothing but, as there's a diagram that depicts this Turing test. If a user does not know if he's interacting with a machine uh, or another human, or in other words, if he's blind to the user, but or in other words, is if the machine learning is if the machines are indistinguishable from humans. In that case, you have successfully designed something that could fool human into thinking that it's a machine. So that's a high level overview of the Turing test. And in 1952, we had our first learning program, where this, as you can see, there's an image of the first learning program of Arthur Samuel, a scientist who came up with a game of checkers. And then in 1957, we had our first perceptron model, or the neural network model. And as I've put a diagram of the human neuron. So there was a lot of research on trying to understand how we think biologically and how we can transfer and design systems in a similar way to how machines can think. Because understanding our human thought process is very important to master and make machines also to learn and think in the same way. So that was a very first attempt towards understanding the human neuron and building a perceptron model. And then from 1960s to 90s, these are what are the decades of theoretical research and understanding. So we had decision trees, different types of methods that came across these decades. So I've listed three important scientists who have contributed to field of deep learning as for machine learning. So on the left is Yann LeCun, a French scientist American scientist and mathematician who came up with the first convolution neural networks. In the middle is Geoffrey Hinton, a British mathematician who basically gave a lot of theoretical understanding towards Boltzmann machines and artificial neural networks. And on the rightmost is Joshua Bengio, who's a Canadian mathematician and computer scientist who built a lot of work on um, like attention models and the more recent adversarial networks and other developments. So these three people recently won the Turing Award and they're also nicknamed the godfathers of deep learning. And in 1977, this is perhaps when everybody started talking about machine learning, deep learning in the world. Probably the first wave in terms of machine learning is when IBM's Deep Blue, they built a system that could defeat the world champion Kasparov, the Russian grandmaster. And that's when people really started understanding, yes, this is where most of the intelligence is, because beating a grand champion in chess was the trademark set as to how intelligent a machine could be. And once when that was broken, that's when people really wanted to focus a lot of research, interest, and a lot of things happened around after 1997. And this was also around the time in 1999, NVIDIA came up with their first GPU, their GeForce 256. I think that's also a very critical point when once we had our hardware that was able to implement a lot of these theoretical work in the 60s through 90s. And that's when we really saw several work and effort in this field. And in 2005, this is an image of Stanford Stanley. There was an DARPA, which is an army-based research organization in the US, like the DRDO in India, where they had a competition of an autonomous car race competition. And once the Stanley completed the race, once again, it became a talking point around 2005. And in 2012, we had a first neural network-based model that could win a competition of image classification. And that began the whole deep learning field, or the second wave, in which we are still part of. So I feel like we're still part of the second wave in terms of deep learning and research. And in 2016, there was the Google's AlphaGo, which is a strategic board game, uh, which was a competition. They challenged the Go champion, and the Google's AlphaGo was able to win 5 out of 5 games. So all of these were some turning points where the general public became really curious and understanding the powers of artificial intelligence and machine learning. So here I've covered some of the applications, but here there are also several others, which perhaps that I might have missed is the navigation routing. We have our Google Maps and Apple Maps and other types of navigation systems, which can accurately tell you how much time it takes to go from point A to point B at a specific amount of time, maybe 8 a.m., 9 a.m., peak time. So these are all models that work behind scenes that help us with these decisions. Then you have recommended systems, our Netflix, Prime Video. They are so advanced enough that they are able to understand our likes and dislikes and able to suggest movies and TV shows and other things that are close to our interest. So that's also another active field where machine learning and AI is used. And then there's diagnostics. So medicine and the medical field, including especially this year, due to the unprecedented times, we understand how much of an importance medical fields are. And there's plenty of research happening in terms of trying to use AI with diagnostics, trying to use AI with helping robotics and stuff like that. Maybe another thing, sport analytics. So in most of our sports, we understand like when the commentators, for instance, in cricket, they always come up with statistics like 60% of the time, the team that batted first has won the game, or no team has lost when they have scored 200 runs in the first 19 overs and statistics like these. And these are some models that are built based on data and trying to give us insights. So we see it used tremendously in sports analytics. Of course, stock market prediction, industrial automation. There's several amount of robotics and AI-based improvements in warehouse navigation. So warehouses are huge, which needs to, we have like this 2-day delivery, same day delivery in our e-commerce systems. And that has become possible because of automating our warehouses through robotics and stuff like that. So probably last one but slide that I wanted to also focus equally important is on career opportunities. So I was looking at some of the opportunities that is active in this field. So these were 3 quotes that I found were interesting, which I also took from the LinkedIn's 2020 Emerging Jobs Report, India. So the first one, technology continues to dominate our emerging job market field. So this was from the LinkedIn job report. And then secondly, India is the second fastest digitizing economy in the world. So this was taken from the McKinsey report. I've also included the links in this slide. So if people are interested, I think these are interesting articles to read and also feel motivated that we are in the right time right now to look in this field and learn about this field because we are heading in the right direction. And then third, on Indian businesses, found 74% believed AI will improve economic growth, cyber growth, uh, global health, and education. So that's from a PwC survey. So I've also taken a screenshot of one of the topics in the 2020 Emerging Jobs Report India. So an artificial intelligence specialist was the second ranked in 2020 on the emerging jobs. And these are some of the top industries that are actively looking at these fields. And some of the skills that are important are trying to learn some basic machine learning, basic concepts of deep learning, TensorFlow, Python, and NLP. They have also listed some top LinkedIn learning courses that I feel would again be helpful for those who are starting out or really curious about this field. Finally, and also an important slide is how we can learn. So there are conventionally our ways have been through textbooks and books, which are also equally important if you want to have a sound understanding of the math or the concept behind the scenes. But there are also these days you have a lot of it at our fingertips, and through uh, the digitization, we have enough resources to learn from some of the top experts in the field. So what was not possible 20 years ago, now we can learn directly from the godfathers, from Jeffrey Hinton and Joshua Bengio, from our homes at anywhere in this place. So that's possible because of these MOOCs, for instance, like Coursera, EDX, Udacity, Udemy. And there's also a good, and there's also equally good MOOCs in India, like the NPTEL and other resources as well. So that's an excellent way. And for instance, in Coursera, there's a course by Andrew Ng on machine learning and deep learning. And that's definitely a course I would highly recommend if somebody wants to start out. And there are also other ways where we can learn by doing, because it's also equally important. One way is to learn by studying, another way is by learning by doing. And that through that, there are lots of GitHub repositories that you can find out by just trying to implement their codes and try to understand how these phases are actually built and implemented. And you also have open source codes for TensorFlow, which is developed by Google, and PyTorch by Facebook. So these two frameworks help you understand machine learning as well as AI frameworks, but they have enough resources to guide you step by step to going from step one to the last step, without having even if you're starting out and you're a novice to this field. So I think this is also an excellent way to learn. And finally, the third way that I would also encourage is through websites like Kaggle. So Kaggle is a competition-based website. So they are really uh, uh, very useful, especially in the field of data science and machine learning. So you have free courses. You also have chance to earn some pocket money by winning some of these competitions. So they give you the data sets, they give you what is expected, and you can compete directly and try to find out where you stand amongst uh, other folks or colleagues in this world, or even if it need not be that stage, to learn by doing some of basic uh, things like through open source, like just object detection or sign detection, digital recognizer, and stuff like that. So I think that's also another excellent way to learn by doing. So yeah, so I think this is what I primarily wanted to cover today. And yeah, so thank you. And thank you for inviting me and inviting me to this conference. I'd like to thank Sudha ma'am, the management staff, and others who have invited me. And yeah, as I mentioned, feel free to reach out to me if you have any questions or guidance in this field, and I'll be happy to help. Thank you.
Thank you so much, sir, for your words of knowledge. It will be a great pleasure for us to listen to you in our future events. Thank you, sir.
Thank you.
Thank
Thank you.
you. I have one question, Mr. Krishna Kumar.
Yes.
Yeah, this is Premchand. Okay, so lovely to listen to you, and really you have come out very well. Thank you so much. And as you rightly said, it's like you said, technology continues to dominate the emerging job market. Yes, I do agree to that. As well, you said 70% of the people, they believe in the economic growth and global health and so on. Okay, fine. But my problem with my students, actually, particularly not only in the college level, but also in the school level, particularly in the higher secondary level, what is my question is, now this technology, it leads to non-productive struggle and frustration for some students. Do you have any answer for this actually? So this technology, particularly, I could give you one example. Recently, in one of our schools, I don't want to mention the name of the school actually. One of the school is, these guys, this technology has led them to a corner. In a corner in the sense, the whole night they misuse this technology. And the production, maybe the struggle, the frustration is more when we just go for counseling. So they have a tough time. Now, how do you substantiate or how do you answer? Now, how can we overcome this kind of situation? When you say that technology booms the whole world. Yes, please.
Yeah, thank you. Thank you for the question, sir. I think it's a great question. It's also a difficult question. But what I would say is, so most of these machines or technology, it's always been there to guide us and enable us to make our lives better. So I think it depends on how we want to look at it. I think we are at a point where we really need to understand uh, also the drawbacks of technology, which is also equally important. I definitely feel it has the upsides as well as the downsides, but I think what is really important is we try to uh, not only speak about the advantages, but also highlight some of the shortcomings or disadvantages or these uh, potholes of technology, which is very important to convey. Because I think in that way, I think parents and teachers, especially professors and teachers, could play an important role when they're trying to communicate with students, try to communicate that it's really important to have a close connection with family, with friends, with teachers. I think if students can think friends and teachers as their as really close and can share things with, I think that's also equally helpful. So I think it's a difficult question. I don't think there's a correct way, but I feel there are always two sides of a coin, and it depends on how we try to communicate this and have a close relationship with our students, friends, colleagues, and have a discussion. So the most important thing is to have a discussion constantly and try to make them think on a daily basis on these things.
Thank you, Krishna Kumar. Finally, only one question. That is, now how long will this technology be relevant and supported? Because even I could say, even this Facebook technology, your WhatsApp group of technology, we are totally fed up, daily morning looking into that, saying hi, good morning, all this. We are totally fed up with all this technology now. Now, how long it will actually this technology be relevant and supported actually? What is your personal opinion on this?
I think from the standpoint of my personal opinion, I think this is not going to go away anytime soon. I think definitely the point where we are right now, I think this is definitely not going to go. But I do feel like it's also important to have some sort of, I would say, I've started to notice there's a lot of discussion on regulations as to how much we can allow big technology companies uh, uh, to have regulations on them. So I do feel that there would be some changes to the way technology companies are regulated as such. But in terms of if it is going to go away or if people are going to be uh, uh, or if people are going to be fed up with using technology, I think that's something probably at least not in terms of anytime soon, because I feel the benefits outweigh the drawbacks, and there's equally for every probably one downside of technology use, there's another story of how technology has saved people, helping right now in the pandemic and stuff like that. So I think if it comes down to benefits, I think in that way, I think definitely not at this anytime soon. So I think if there's a time that for us, our generation to take a keen interest, and that would be right now.
Thank you. Thank you so much, Mr. Krishna Kumar, being with us from California. So thank you. Thank you so much.
Thank you. Thank you, sir.
Thank you so much, sir. A great explanation. Thank you, sir. Now I would like to invite Mrs. Gladys Tangarubi, Assistant Professor, Department of Computer Application, to introduce the next guest speaker of the session.
It's a great joy and privilege to introduce our resource person, Mr. Rohit, was born in Jamshedpur and grew up in Chennai, Tamil Nadu. He is having an undergraduate degree in biotechnology from Anna University in Chennai. He is very much passionate about applied physics and worked in Europe for 5 years in optical physics domains ranging from specialized microscopy techniques to cancer biomarker detection. He holds a master degree in optical physics from University of Rochester in the United States and currently resides in California. At present, he works at a startup as a senior optical research engineer developing augmented reality devices. In his spare time, he loves to play football, badminton, hiking, trail biking, and recently developed an interest in attempting to cook various cuisines. He is none other than Mr. Rohit Prakash, who has accepted our invitation and came forward to spend his valuable time with us. On behalf of our college, I request our resource person to take up this session for a meaningful interaction. Over to Mr. Rohit.
Thank you very much. Thank you. That is a very nice introduction. Thank you, Sudha ma'am, for organizing and inviting us to talk at this international conference. It has been very nice. I've not spoken in a public forum for a long time, so if I'm a little bit rusty, please bear with me with that. And thank you, Mrs. Gladys Joel, for that very nice introduction. Thank you very much. Are we okay to get started? Can we get started right away?
Yes, sir.
On anybody, or can we get started?
You can start, sir.
All right. Right, you should be able to see my screen.
Yes, sir. Visible, sir.
Okay, hang on. Are you seeing my? Are you able to see it full screen?
Yes, sir. It is visible. Full screen is visible.
Okay, fantastic. Right, so I'm going to be talking on augmented reality, like augmented virtual reality, mixed reality techniques. Some of which you might have heard before, some of which might be new, and some of the things are running sort of parallel to what one of the previous speakers spoke about. So one of the speakers, Krishna Kumar, also spoke about artificial intelligence and other technologies related to AI. You might see some tangents over here. There are some new concepts. There are some that you might have heard before. So let's get started. So as Mrs. Gladys Jewell introduced, I'm a senior optical research engineer in San Jose, working in San Jose, California. I grew up in Chennai for most of my life. I was born in Jamshedpur. I was born in the now Jharkhand. I grew up in Chennai. My mom and dad are from a Tamil-speaking family. We spent most of my time in Chennai, and at one point, I decided I wanted to step out and explore a little bit more. So I decided to go to Europe to try to see what's new, what's fascinating in applied physics, and try to learn more in this field. So I spent a few years over there. Then I moved to the US. I completed my master's degree, and I'm currently working in an augmented reality display company. All right. So what are we going to see in this talk today? So I thought I'll give you give everybody who's watching this talk a quick outline of what this technology is about, where it all started, how did it look when it got started in the early phase, and how it looks today, and in the span of about 65 years, how the development has been, what have been the major breakthroughs that led to excuse me, that led to some of the key developments that we are seeing today. People have thought of all different kinds of applications for this technology. Everybody is welcome to ask. I'm pretty sure they've set aside some time for questions. Feel free to ask any technical question, anything related to this field. I'll try my best to answer it. So some potential applications, some interesting areas of research, which I find interesting. Hopefully you guys will too. There is this new technology developing. Okay, what are the new opportunities that are coming up in India? What are the new opportunities that are coming up around the world? Just to give a flavor of somebody learning computer science, somebody doing learning computer science and mathematics, right? Be it in Anai Violet or anybody else from anywhere who's tuning into this conference. So what kinds of interesting opportunities are out there? And then we'll probably close with some, we'll have some final thoughts, discussions. We'll have some closing remarks, and then we'll have some time for questions. All right. First of all, there are some terminologies that need to be introduced. Everybody uses like augmented reality, virtual reality. Those are sort of like hot keywords today. What do they actually mean? So they are all part of the same display technology, but they're all slightly different from one another, right? So in general, like an augmented or a virtual reality device helps you visualize something that's virtual, that is not exactly real. I'm pretty sure everybody understands that. Those are virtual objects, but in some cases, you can actually interact with those virtual objects. I'll try to give as many descriptive examples as we go through this talk. There'll be some just pictorial only examples, sometimes video examples. Um, so amongst this augmented reality, virtual reality, and mixed reality technologies, right? So this augmented reality consists of a subspace where the user who's immersed in this augmented reality technology, right, or having such a display in front of them, they are able to look at real objects. For example, I have my phone in front of me, right, which is a real object. I can touch and feel it. But at the same time, somebody wearing these augmented reality glasses also sees virtual objects, something that you would only see on a phone now pops up in 3D in front of you, and you can interact with it occasionally. In some instances, it's only for viewing. Whereas in virtual reality, it's almost as if there is a headset which you're wearing. For example, let's imagine I'm wearing a headset and this display device is attached in front of my eyes, right? So once you do that, you don't have a visual cue of the outside world. That some people sometimes see as a drawback, but what it does is it gives you a fully immersive experience. That's what people in this field call like a theater-like experience, right? You are immersed and looking at that video, and you get like a as if you are in your own personalized theater, right? Mixed reality is simply a hybrid of the two, being able to switch between one and the other. We can go into more details later, how one can do that and why it is interesting to do that. Right? For example, okay, here is an example in front of you. This is one of Microsoft's augmented reality headsets. It's called the HoloLens. Here, for example, the user is wearing it as it's shown in the picture. So you can see that you are clearly able to see the room around you, but also at the same time you're looking at virtual objects, right? You're looking at some little avatar pop up in front of you that's able to occasionally communicate with you. You can talk with it. Sometimes it responds just like your Google Voice assistant or your Alexa or something like that, right? Then this is how it would look like. Let me know if you're not able to hear the audio, okay? This is a small example in which this video is being shot through somebody who's wearing one of these augmented reality headsets. In this case, it's the Magic Leap 1 headset. This person is wearing the headset. He's able to look at people and like real objects in around them, like the furniture in the room, a monitor or a table or something like that. At the same time, they're able to see this virtual content, right? So that's what this is trying to depict. So that's what I was talking about. So in some use cases in augmented reality, you want the user to be able to interact with the virtual environment, right? So in this case, the creator of that content was talking about how he would like to have sort of like an aquarium effect. This I believe is called the Undersea. You're welcome to check it out. We'll have discussion later if you want to go find some of this content yourself and check it out for yourself. So this app was called the Undersea, and the idea of that was to create like an immersive aquarium kind of experience, right? Where you're able to see colorful fishes, which you'll have to otherwise spend several thousands of rupees to get a flight ticket to go scuba diving and to go see those fishes, which you can actually, all of that experience is now brought to you, and you are able to interact with that virtual environment. So that's an example of augmented reality, right? So, but for virtual reality, now you are completely immersed in this virtual environment, right? You're not able to look at like family members or friends sitting around you and things like that. So here is an example of a typical virtual reality application. So in this application, sorry for pausing. In this application, the creator is trying to give you an experience as if he's taking you back in time through history to have like a direct one-on-one conversation with a famous artist. All right, there's just sort of a dip your toes in the water introduction to these technologies. Moving ahead, so somebody some point in time had this idea, right? Okay, they imagine that we are able to look at the world around us, but how would it be to capture it on video and probably just see it in a more immersive 3D manner, right? Somebody had that idea some time back, and then it sparked off this entire new stream of ideas, a completely new field called augmented and virtual reality. Right? Where did it all start actually? So here is a side-by-side comparison. So what I wanted to show here is some of you might have seen it, some of you might have lived through it, some of you might not have lived through it. Like how computers that were the size of an entire room, and it used to create enough heat to keep the building warm. From that scale, they have gone down to being able to fit in the size of your palm. Many people don't understand how much computing power just your phone has, right? And all of that has been possible because of certain developments, right? It's just like that in the AR and VR industry also, right? It started way back in some of the early observations of stereoscopic observation instruments, right? They date all the way back to like 1800s, early 1800s, right? Wheatstone, from the very famous Wheatstone Bridge or the Wheatstone Circuit, right? And Brewster, they were all scientists back then who were playing with different instruments, and they discovered ways of projecting things in 3D, right? Then 130 years later, even Sutherland, then working, once used to work at Bell Labs, I believe, he stumbled upon a different idea on how to achieve this sort of an AR VR effect, and ever since Sony has come up with their own device. Microsoft, HTC, everybody, I mean, many big companies, they have jumped on this bandwagon, and they've come up with their own devices. But one thing you have to know is how this wearable gadget went from being an extremely bulky, huge device all the way to a very compact wearable device that you can wear on your head and not feel uncomfortable like moving your head around, right? So started off something like this, right? It weighed a few kilos. It needed to be mounted on a platform. It had like different receivers, like a huge power supply at the back, two very bulky set of optics to be able to see things in 3D. And from that, we have gone to fast forward from 1960s to today, right? 2020, 2015, and later, we've got devices that are super sleek and compact and wearable, and you can. It's on a wireless platform. It's powered by a battery, not quite the same battery, not quite the same size as the one that drives your cell phone, slightly bigger than that, to be able to give you, say, like 2 to 3 hours of operation, right? That's how it has progressed from very bulky equipment to a very compact form factor. Some of the things we'll discuss more in detail. Some of the things that helped uh, get down in size and be very power efficient, be very size efficient, right? Be in a very compact form factor and be very optically efficient, right? There have been many developments along the way, right? It had to span all the way from some cutting edge breakthrough in material science and optical physics and electronics, semiconductor technology, you name it. It spans the full breadth of technologies to uh, some cutting edge developments in all of these fields were required to make this possible, right? That's why it has taken what, say, 50 to 60 years from the 1960s to today. It's taken that much time for all of these progressive developments to catch up and then end up with this very functional device. So what were some of the key developments, right? Nano fabrication. Some of these optics, they look like your normal pair of glasses, but they are not your normal pair of glasses. There are some micro features etched onto it. They have a specific functionality, like I was talking earlier. There are some material science breakthroughs. There are some fabrication breakthroughs. There are some semiconductor breakthroughs. All of those had to happen to make this possible, right? Some of the key highlights were optical microfabrication, very small optoelectronic devices, and very different kinds of display architectures. It's not your typical TV kind of display or a lap or the display that you see on your phone or your laptop, or it's not that typical kind of display. It shares quite a lot of the same technology, but people had to innovate to bring it down to like very compact form factors and uh, very low power consumption working modes. All right, enough of me talking. We'll take a short break and see an interesting video. At least I find it quite interesting. I hope you guys do.
Audio is missing.
The audio is. I had to edit the audio out to keep it within a certain bandwidth to be able to fit in this presentation. But there isn't any audio. It's just a summary of all the interesting processing steps and how they make such an instrument. Right? Just a quick recap of everything that goes together to make such an equipment.
Okay.
There's that very fast optoelectronic scanner that's going to create the display. That's the lightweight frame and the display itself in a glass-like form factor. That's sort of the final product, and some people demoing it. And here they have highlighted an interesting use case. For example, if you're trying to do some mechanic work, or if you're trying to do some repair work, an equipment like this can give you sort of real-time input and sort of guide you along the steps, right? Or be it an operating procedure, or it could be an interior decoration or an art studio, or trying to paint a picture of trying to see what sort of interior decoration goes with what. So here they are demonstrating how inside the inside operation of one of these equipments, right? So you have like three color LEDs or lasers, depending on whichever technology one chooses, right? So there are three that are at least required, right? The primaries, that's the red, green, and the blue. So with these three primary colors, you're able to create any other color by mixing these colors in the right proportion. So in equal proportions, it's going to create white, and in some other unequal proportion, you're able to create all the other colors within the palette of colors that the human eyes can perceive. So here it's an animation where they're showing that the lasers are combining to create white light in this example, bouncing through a few different optical relays and an active mirror scanning system like the one that you saw earlier, and it's bouncing through a few other optics before it comes up. It shows up on the user's eye as an image. So here is another key technological development that was required to make this possible. So on one side, people working on this technology had to come up with novel ways of illuminating, novel ways of projecting it, and novel ways of relaying it to the user, right? And here is another key development in this pipeline. So it's in this field, it's called a MEMS system. We don't have to go into all of the details. Some people might be aware of what it is. MEMS here stands for like a micro electromechanical system. So it's basically an electrically actuated, but a mechanically moving mirror that's going to scan really fast and to paint the entire screen pixel by pixel for you. Right? And that's how the user sees the full image. It's being developed pixel by pixel, but the raster scan is so fast across the screen that you don't see the individual pixels developing, but instead your eye integrates over that scanning time and sees that entire image. Right? That was another key technology that had to be refined to make this compact form factor and efficient operation possible. All right, so that's the gist of what this technology, how it developed, what are the key components in making this technology possible. I hope you guys are following until now. If there are some questions, please make a note of it. We'll get back to it towards the end of the session. Okay, now we have this new technology in hand. We need to do something meaningful with it, right? What good is a technology that doesn't find an interesting use case or an application, right? Some of these applications that I'm going to show you, some exist already, and some are going to come in the near future or in the next 3 to 5 years. Some of them don't exist but have the potential to be implemented, right? So you can straight away imagine something like entertainment, like personalized entertainment, or something to do with gaming, or especially given the current scenario, right? Everybody is working remote. Students are studying remote. So, and in general, we tend to learn better when we are learning audio visual, right? Instead of simply writing something on the whiteboard, or instead of simply flicking through a book full of pictures, right? Audio visual learning has been proven to be the most effective medium. Audio visual means there is an audio instruction, or sometimes a written instruction, but also a video to follow along and try to visualize what that other person is trying to tell us, right? So education is a very good use case for this sort of technology. It doesn't have to be personalized. It could be on a more it could, like one device like this could serve multiple different people, right? Things like practicing and getting your procedure right before surgery, doing some like virtual travel, or these are just few interesting use cases. And this is a particularly interesting use case where some recent research at the Stanford Medical Center, they have been using this sort of immersive audio visual medium to sometimes treat patients with like sleeping disorders, sometimes sometimes individuals who have anxiety or stress or sleeping disorders and things like that, right? Sometimes PTSD, sometimes if somebody had a very traumatic incident in their life, God forbid, they had such an incident and they're not able to overcome it. Some psychovisual researchers are looking at how we can use these immersive medium to try to help ameliorate some of these conditions. Right? Some interesting and active areas of research. My particularly favorite topic, because I do a lot of research, and that's why I have a job, and hope this this section still has a future. But some of the things, jokes apart, some of the things that are particularly interesting, right? The complexity of this problem doesn't stand out immediately when we look at it, right? When you're having such a compact form factor equipment sitting right on your head, right? There are multiple different problems or interesting aspects that need to be tackled to deliver a very good experience, right? We have seen some of the challenges earlier. You had to come up with a novel display solution. You had to come up with a novel illumination solution, which is the light source. Some companies prefer laser light sources. Some people prefer, LED light sources. There are multiple different ways of making this happen. At the end of the day, to try to give you a very immersive, high quality experience, there are multiple things that need to come together, right? Imagine something sitting on your head, and your head is free to move in any which way it wants, right? I mean, we're not going to be moving our head randomly, but we have the liberty of turning our head, either seeing up or down, and then independently, without the head moving, our eyes can move from like side to side or up or down or any of those compound angles. So now you got to not only be able to use your battery power effectively, find a good display solution, be able to track where the individual is gazing. So that's some of the gaze related issues that we have to solve, right? If the person is looking straight, the content has to appear right in front of them, but without their head rotating or moving, right? If the individual is gazing to the upper right corner, for example, and only the eyeballs are moving, then the content being displayed has to move from the center and be tracked to wherever the eyeball is moving. And this typical window within which the eyeball can move and still see content is called the eye box. As long as you're staying within the eye box and you're still moving your eye from side to side or up or down, the content should be able to smoothly follow your eye, right? It's called smooth pursuit, or sometimes it's called saccade. Saccade just means like how smoothly the eye moves and how smoothly the content follows it, right? Then the other thing is, you got to know where to place some content, and you got to know where to not place some content, right? So the device should be able to map the outside world, should be able to map the room around it, right? And locate where to place these virtual objects. And then once the head rotates, there are some head pose issues, right? So there are multiple things that need to be solved, and not only solved, they've got to be solved in real time, right? I mean, it would not be a great product if you're looking somewhere, right, and there is no content, and suddenly the content appears, right? That's going to be sort of it's not going to be a very compelling experience. So not only do you have to display content, understand the orientation of the head, understand the compound rotation angle of the eye, where the person is gazing, be able to map the environment around you, and place virtual content all in real time. Some of those are solved problems. Some of those people have found solutions to some of those aspects, and some of those aspects are still topics of hot research. And those are some of the things that are highlighted here. Not to mention the form factor, how much power these equipments take up, right? So in brief, we can sort of like categorize it into these categories, right? So you want to be able to have a low power, long battery operation, so that the device doesn't like switch off within like 20 minutes. It all has to integrate seamlessly to form this very compact system level performance that we were talking about. And it still has got to be in a form factor that people are comfortable wearing, that it's light enough, not hot enough, and still, still cool looking enough, and still functional. So those are some of the most active areas of research, in case anybody is interested. All right, great. Now we have introduced a new technology, discussed what are the key components that need to come together. We have sort of outlined um, what are the interesting research areas and topics that need to be challenges that need to be tackled to make this a very compelling experience. By that I mean, why would somebody move away from an existing technology like a TV or some other form of display and move to this upgraded version of display, not only display, but it can do a whole lot of other things. Why would people move away from this? And we have seen what some of the challenges that need to be tackled are to make that transition possible, to make that transition seamless. Now there's always this open question. Okay, I'm interested in this domain. What do I do next, right? Where are the opportunities? How do I who do I reach out to? Like, who do I talk to find out more about so within India, I could think of two major forums. One is the VR AR Association. It's being run by a few notable industry personnel and some people who are some of the IIT alumni, particularly IIT Bombay and Delhi. Those alumni they've gotten together to sort of summarize a framework within which they are saying, okay, these are the key hardware challenges to be tackled. These are the key software challenges to be tackled. These are the key mass manufacturing challenges to be tackled. So that's one very useful forum. And there's a second forum called it's basically like an innovation cell where VCs like venture capitalists and people with who think they have compelling ideas can get together and discuss and have their ideas funded. This is also a spin-off from very some notable alumni from IISCs and IITs. So these are some places within India that you can look for some more information and find out more about where work opportunities are, what kinds of job opportunities are available. So this might be a good forum. So on a more global scale, we have quite a few players, right? We have players ranging from let's say like mobile electronics manufacturers to all the way from players like Samsung, Intel, who who specialize in semiconductors, all the way to hospitals and medical centers who are interested in some of the other applications that you were talking about, right? Can we use such immersive technologies to handle or ameliorate individuals with sleep disorders, with depression, with anxiety? Can you overcome fear and things like that? There are whole lots of research going on in this domain. So you have quite a few players. I'll be more than happy to discuss a few in the session later. So these are some of the big players from around the world who are rather active in this domain. So in conclusion, I'd like to say that there have been some very exciting developments over the last 20 to 25 years. And as a result of this new hardware and new developments, we have seen also some very interesting applications developing hand in hand. That's always a positive sign. Any technology without an application will soon go out of existence, right? So you have to find an interesting and a meaningful use case that people are interested in and that adds some value. So such meaningful applications have been developing side by side. At the same time, there still are some open questions. There's still battery life, energy efficiency, all of these problems still need to be tackled, especially when you're going wireless and mobile. If you have to carry this device around without being connected to a power supply, you still have to be able to do all of these things, right? What about cost and scalability? Okay, we are able to manufacture such a device, but what's this going to cost us? Will I be able to afford it? Will the masses be able to afford it? So that's another thing to be tackled, right? Not to mention there are intense health and safety aspects that are being assessed for just like any good use case for any new electronic application that comes out there. So this is how I would summarize where this industry stands, and just in summary. So those are my closing remarks, and feel free to ask any questions. That's all I've got for today's presentation. I hope everybody enjoyed it, and hope we have an interesting discussion.
Thank you so much, sir, for your wonderful speech.
Back to the host.
Thank you so much, sir, for your wonderful speech and valuable explanations. Once again, thank you, sir. Just a gentle reminder for the few viewers, kindly fill